right, so this is the video for number 12 and 13. 12 says solve the system at the right using your method of choice. I think the most appropriate method here, since we have x equals for one of them, is substitution. So we would take this and replace x in the other one with that. So when I do that, I'm going to take the first one, so write -5, and then taking what x was and putting in the new x, we're going to put parentheses, -4y minus 27, close parentheses. Done replacing stuff, so then I'm just going to continue to write the other things that were in the top equation. So -3y equals 50. The whole reason that you do this is so that you get one variable. See how you just have y right now and you don't have x and y? That makes it so you can solve for one variable and then go back and solve for the other. If you start doing substitution and you still end up with two variables, that means that you did something wrong and you need to go back and figure out how you do that. Most of the time when you do end up with two variables and you did something wrong, it's because you left what was there before. So what I mean by that is it's because you left that x instead of taking it out and replacing it. So now to solve this, we are going to distribute that -5. So -5 times 4 is positive 20y. And then -5 times 27 is going to be a positive again, 135. So remember, negative times a negative is positive. Be very careful about that. Then we're just writing -3y because it's not inside the parentheses, so we're not distributing the -5 to it, and then equals 50. So now we're going to put the y's together as we see them. So 20y minus 3y is 17y plus 135, I'm just rewriting that, equals 50. Then the next step will be to move the 135 to the other side of the equation to get the 17y alone. So I'm going to take away 135 from both sides. So 17y will equal 50 minus 135, which is -85. And then the last step to find y would be to divide both sides by 17, which is going to give us y equals -5. Be careful about these positives and negatives because you're going to need to use that to find the other part. So now that we have y, we need to find x. You get to go back to your two original equations and you need to pick one. It doesn't matter which one you pick because either way, if you plug in the correct number there, you will get out the answer for the other one. I do think one would be easier than the other. Looking at the bottom one, we're looking for x and it says x equals. So it's going to be a lot easier to get an outcome. If I try to put it in the top, I can still do it, but I've got to move things around in that equation to get my x equals. So I'm going to just start with the second one and then plug in -5 for y because that's what we got down here. Again, using parentheses, and then I'm going to actually solve it. So x equals -4 times -5 is positive 20 minus 27. So x equals -7. So then remember, the whole point of this is you've got two lines, they're crossing at a point. They're intersecting at a point, so I'm going to write my answer as a point, -7, -5. Remember, it's supposed to be x, y. Make sure you put those parentheses there too. If you just write -7, comma, -5, and that's it, that's just a list of numbers. You need to be clear about what you're saying there. All right, 13, it says examine the system equations below. This one we're going to graph, so it says solve the system graphically and algebraically. So we only did algebraically for number 12. Verify that your solutions from the different methods are the same. So first we're going to graph. So this is the x-axis and this is the y-axis. You always start with the y-intercept first. So I'm going to start with +6 for the first equation. And then my slope is -2. So that means -2 over 1. We always want to write that as a fraction so then we can count that slope. So I'm going to go down 2 on the y-axis because it's change of y over change of x for slope. So down 2 and then to the right 1. You want to make sure you only make one part of your slope negative. If you make both parts negative, that becomes a positive, and that's not what you're looking for. So keep going down 2 over 1, and I'm going to do this until I have no more space on my graph because I don't know exactly where these two lines are going to cross each other, What if I only put a couple points and I didn't find what I want? Oh, did you see what I did there? I just went up 2 to the left one, because 2 over -1 is equal to -2 over 1. It's the same thing. So I did all those. Okay, so that's my first one. Now my second one start at -9. And then it's saying go up 1 to the right 2, because right is positive. So up 1, right 2. Up 1, right 2. Oh, we're getting close. Oh, right there. So I'm going to stop because they already crossed right there. So the answer of where they cross is 6, -6. So 6, -6. So that's their intersection. So when I solve it using algebra, when I solve doing on the number business, it should be giving me 6, -6 as my result. So let's do that. So if it's y equals -2x plus 6 and y equals 1/2 x minus 9, this is a little different than this last one up here because I only had one variable where it was by itself, but here I have both. So I get to set those equal to each other. So it's a lot easier actually. -2x plus 6 will equal 1/2 x minus 9. So now I'm going to solve. So excuse me, I'm going to add 2x to both sides. You could have gone a different route here. 6 equals 2.5x minus 9. I'm going to add 9 to both sides. So 15 equals 2.5x, and then I'm going to divide both sides by 2.5, and x equals 6. Is that true? Yes. So we're doing well so far. And then the next one is to find y. So I'm going to use the equation without a fraction. You can use the other one, but I'm going to avoid that. So I'm going to just write y equals -2x plus 6. It's the same process for the second part, just as that other one. So I'm going to plug in 6 for x and then see what I get for y. So y equals -2 times 6 is -12, and then plus 6. Y equals -6. And that again is true. It is 6, -6. And then it says, what is the relationship between the two lines? How do you know? So are they parallel, perpendicular, or neither? We're looking at the slopes to help us find that. So we're going to write -2 was the first slope, and then 1/2 was the second. Remember, -2 can be written as -2 over 1. So we definitely know they're not equal, so they're not parallel. And then to see if they're perpendicular, that would mean they need to be opposite reciprocals. So one is plus and one is minus, so that's good. And then they do flip. Although it says -2 and then 1/2, you know -2 is -2 over 1, and you always need to remember that. So this is perpendicular, because the slopes are opposite reciprocals.